everyone, this is Miss Nguyen. I realized partway through today that I forgot to post a review of the macromolecule identification practice worksheet, and I just posted a key for it. And in this video, I'm actually going to walk you through the most common problems I know the students had in this worksheet, both in this past and specifically last Friday when I was stamping your homework. There was a few red flags I noticed for misidentification by students. So let's go over this worksheet. All right, so I feel like for the most part, some of them are very straightforward. This is a lipid, specifically it's saturated fatty acid because there's no double bonds in the carbon or between carbons within the fatty acid tail. However, I did notice some of you misidentified this one. This is a lipid, it is specifically a steroid. You should be familiar with what steroids look like for lipids. Compare that to a carbohydrate here, here, and here. These are rings with O in the corner of the rings holding hands. Well, if you look at the lipid here, though there is some O oxygens in it, that is not in the rings themselves. If you look at the rings, there are no oxygens in the corner of the rings. There's also no nitrogen in the corner of the rings. When there's nothing labeled, it is just carbon and hydrogen. And hydrocarbons are always nonpolar, and they will not mix with water when you have a molecule that has a significant chunk that is just carbon and hydrogen, okay? This one was a nucleic acid. I feel like most of you got that. However, then when we get to other materials with phosphates, it falls apart, okay? So I'm gonna scroll down a little bit, but just to remind you what a nucleic acid is it must have a phosphate. It must also have a sugar ring, and it must also have a nitrogenous base. A nitrogenous base is a ring with N in the corner. What I noticed with students is they misidentified molecules if they see a phosphate and nitrogen in it, and they just go, oh, it's nucleic acid. It is not. A nucleic acid must have a sugar ring, and it must have a ring with N in it in addition to the phosphate. So let's float down this worksheet all the way to the bottom of it where a lot of you messed up, because a lot of you just stared at this molecule here and said nucleic acid. It is super not. There's a bunch of things in this molecule that make it non-nucleic acid. Number one, the only thing that could make you possibly think it's a nucleic acid is phosphate and that there's a nitrogen here. But that nitrogen is in a ring with N in the corners. So already we're missing a nitrogenous base. Second, we have no carbohydrate rings here. There's no sugar ring anywhere in here. So nucleic acid off the table. But what we do have here, despite the phosphate here, is the zigzags. And again, if you recall, zigzags are a shortcut for writing hydrocarbons, molecules with just hydrogen and just carbon. And even though it's written quite small in this picture, this zigzag is quite big. It's pretty much as big as this molecule over here, this fatty acid. These are both fatty acid chains. That makes this a lipid, not just any lipid, a lipid with some phosphate attached to it, a phospholipid. This nitrogen here is actually the R group you kind of see in this picture of a different phospholipid, which again has phosphate and two lipid tails or fatty acid tails, in addition to sometimes a replaceable group that could have nitrogen in it. So this non-nucleic acid, not a nucleic acid. What makes something a nucleic acid is the presence of not just the phosphate, but the rings with N in the corner, the nitrogenous bases, and the sugar ring. Please do not forget this. All right, other than that, I feel like this worksheet is pretty straightforward in terms of identification. The one exception, I believe, is this guy over here, which is actually glycerol. Now, you may have identified it as one of two things. It's actually a carbohydrate. What makes it a carbohydrate? It's CHO with an equal amount of carbon and oxygen in it, which makes it very polar, which means it can't be a lipid by itself. However, if you wrote lipid next to this, I wouldn't necessarily dock you, but this molecule is not necessarily a lipid, but it is often found within lipids, like this guy. The glycerol is here to hold the lipid fatty acids, all right? So the glycerol itself, though technically a carbohydrate, is most often seen in our class as a component of a lipid, all right? But the thing that makes this lipid a lipid isn't necessarily the glycerol. The glycerol is really just glue that is holding the thing that actually makes this lipid a lipid, the fatty acid tails, these hydrocarbons that don't like water. The presence of these hydrocarbons, because they're hating on water, that makes these molecules avoid water, which then by definition qualifies them as a lipid, generally speaking. All right. The only time I would say something could be hydrophobic and not a lipid is if it's only briefly found in an R group that is part of a protein chain. But when you have a huge section that's hydrophobic, that is a hydrocarbon, pretty much always lipid. All right. On that note, go ahead, double check the answers on this worksheet. And if you're still really confused, I would suggest you watch the lecture video that is also posted on the Google Class link as well. Bye.